Hey everyone, and welcome back to Dietitians and Nutrition Support. Today we're throwing it back to the basics and we're going to be talking about carbohydrate digestion, all the things you need to know about where it's happening and what's going on. So first, let's think about what are carbohydrates. Well, carbohydrates are one of our three macronutrients, carbs, protein, and fat, that are going to provide calories and all sorts of nutrients, obviously, to our diet. So carbs are super important because they are the primary energy source of most all cells in our body. They are also the preferred energy source for specifically brain cells and nerve cells. So all the things happening in our nervous system are really going to rely on carbohydrates for their fuel. Carbohydrates are composed of carbon, hydrogen, and oxygen, and you can see a few different forms of those here. And you'll see that good sources of carbohydrates come from things like fruits, starchy vegetables, grains, yogurt, milk, and other dairy products, and of course, they're going to be found in enteral nutrition. So let's look at what carbohydrates can get classified as for their different types of structures. So our whole class of carbohydrates breaks down into two subclasses, the first being simple carbohydrates, sometimes referred to as sugars, and the other being complex carbohydrates. Within the category of simple carbs, we can see two different subclasses, the first being monosaccharides and the second being disaccharides. As you can probably tell from the name, the mono part means that there's going to be a single unit, not a whole long chain of things, whereas a disaccharide means that there's going to be two units that are stuck together. So these one or two sugar molecules, if we are looking at monosaccharides, are one sugar molecules. You'll see probably everyone's favorite, glucose, as well as fructose and galactose falling into that category. And you'll see in the disaccharides category, sucrose, maltose, and lactose. These disaccharides are all just combinations of two different monosaccharides put together to make that two-length chain saccharide. So for example, a maltose has actually glucose times 2 makes one maltose. So if we're looking at the complex carbohydrates, we're really looking at anything that has a chain length greater than 2 because all of our simple carbs are either 1 or 2 chain sugars. Within the complex category, really we're just looking at polysaccharides, poly meaning many. Within the poly category, we're seeing starch or fiber. You obviously probably have heard of fiber before, and we'll get a chance to speak a little more about the structure of fiber and how it gets broken down in the body in a little bit. And then you'll also see glycogen within this category, which if you're familiar with anatomy and physiology, you might be recognizing that as the storage form of carbohydrates in the human body as well as in other mammals, that storage form in the liver or in skeletal muscle. So in everyday human diet, we typically get a mix of both simple and complex carbohydrates, but if we're thinking about enteral nutrition formulas might be a little bit different. So for the most part in enteral nutrition formulas, we're going to see a mix of mono and disaccharides. For the most part, maltose, which is that 2-glucose chain, is going to be the most often detected disaccharide, but really there's just a mix of all sorts of mono and disaccharides typically seen in enteral nutrition. You'll also see in some enteral formulas the use of polysaccharides. You've probably heard of fiber-containing formulas, so you could have some fiber found within that enteral nutrition. Another category of carbohydrates that's been more recently added into some enteral nutrition formulas is fructooligosaccharides. These are short chains of fructose that all get linked together to make an oligosaccharide, which really just means that it has a chain length between 3 and 10 monosaccharides. This is a kind of prebiotic that can be used in the colon and fermented by the microbes that are in the colon into short-chain fatty acids, which can help to support gut integrity and have other benefits once they're absorbed into the system. So these are kind of the clusters of different types of carbohydrates you see in the human diet and the different types that you'll see specifically in enteral nutrition formulas. So you might be wondering, how much carbohydrate does one person need? Well, the amount that a person might want to eat or choose to eat can be dependent, varying based on their dietary preferences and things like that. But the amount of carbohydrate that someone actually needs, we're going to look to the United States Department of Agriculture recommended dietary allowance, which is a type of dietary reference intake for those carbohydrates. And they recommend that a person, both males and females, and adults and children all get 130 grams of carbohydrate per day, at least. So this 130 grams is based on the amount of carbohydrate that is needed for the brain to function adequately. This is not enough carbohydrate to provide energy for other activities of daily living and other things that might require energy. So this is really just enough to get the brain functioning appropriately. You'll also see that with the other macronutrients and with carbohydrates that we have something called an acceptable macronutrient distribution range, or an AMDR. That AMDR is going to give us kind of a ballpark as to not just the minimum amount of the carbohydrate that a person needs, but the kind of average range that a person will eat throughout the day. Most people have an AMDR of carbohydrate intake that's between 45% and 65% of their total daily calories. In specific, you'll also see most recommendations telling people to eat carbohydrates that are focused on fiber-rich carbohydrate options. So then that begs the question of, how much fiber does a person need? Well, we don't necessarily have a recommended dietary allowance, which is a kind of the top choice for dietary reference intake we can have, but we have a dietary reference intake that's an adequate intake level for fiber. So in terms of fiber, the adequate intake reference that is recommended for females is 25 grams per day, and the recommended amount for males is 38 grams per day. You can also use the equation of 14 grams of fiber per 1,000 calories as another way to determine how many grams of fiber someone might need throughout the day. For the most part, the U.S. diet is often quite low in fiber, so a lot of people need to get more fiber in their diet. For the most part, foods are going to be the best source of fiber, although there are supplements for fiber that someone can take. There's two primary types of fiber, the first being soluble fiber. This fiber is going to bind with water and create a gel-like substance in the GI tract during digestion. It actually is going to slow down digestion because of that gelling. Psyllium fiber is a common example of soluble fiber that you might see sold as a supplement. Adequate fluid intake is going to be really important when we're seeing that soluble fiber intake, because like we said, the soluble fiber is going to bind with water and create a gel. So if you don't provide enough water, it's going to have a hard time gelling, and this can kind of cause issues with a higher amount of fiber in the diet. So we really want to make sure we're getting all that fiber and we're getting plenty of water as well. The other type of fiber is insoluble fiber. Insoluble fiber does not gel up with water, but it will primarily be used to add bulk to the stool. Insoluble fiber is a little bit opposite of soluble fiber. It's actually going to speed up the transit through the GI tract. If we're thinking about this idea of carb digestion, it's sometimes helpful for us to know what our end goal is. And the end product that we're hoping to get to from the consumption of our carbs all the way to the absorption in our GI tract is going to be the form of monosaccharides. So like we just talked about a little bit earlier, that's going to be that glucose, fructose, and galactose. If we're talking about carb digestion from the perspective of someone who's actually going to be eating orally, we'll start out first at the mouth. There's going to be two types of digestion happening at the mouth, or some kinds of breakdown. The first is going to be physical, which is going to be the chewing of the food, the mastication, and breaking down all those larger bits of food into smaller bits. And then second is going to be the start of enzymatic breakdown. So in the mouth we have something called salivary amylase. We know a few different things here. We know first that salivary is saying, okay, well, it's probably from some salivary glands. Second, we know A's refers to the fact that it's an enzyme, and we know that the amyl is relating to starch. So it's pretty easy for us to say that this is a something coming from the salivary glands. It's going to be breaking down starches, and it's an enzyme. So in the mouth, we're having the chewing, and that's going to help break down our carbs, and then we're also having salivary amylase that's going to start to break down those larger starches into smaller forms of starches. And so obviously our goal with carb digestion is to get all the way to monosaccharides, but we're not quite going to get there just from this action in the mouth, so we still have a little bit more to do. Keep in mind that if you have someone who's on enteral nutrition, that means that they're not going to be eating orally, obviously, so they'll be getting their nutrients delivered below the mouth, so it will skip this step. Once the food goes from the mouth all the way down the esophagus into the stomach, we actually see a lack of digestion of carbohydrates happening in the stomach. So the stomach acids, as you probably know, the pH of the stomach is quite low because there's a lot of acids going around, and stomach acids can actually inactivate the salivary amylase, so the enzymatic breakdown we were just seeing in the mouth, that's not happening anymore. You may see a little bit of carb breakdown from a physical perspective in the stomach, but for the most part, we don't really see lots of carb digestion happening in the stomach. So again, if you're feeding enterally, once you hit the stomach, remember that we don't have any real carb digestion that's happened as of yet because we bypassed the mouth, and in the stomach, there's not really a lot going on. So we're really banking on some things further down in the digestive tract to be able to help us break down those carbs. So the second place that we're going to see carb digestion happening is going to be in the small intestine. Within the small intestine, this is going to be the site of a majority of our carbohydrate digestion. So if we look over here on our diagram, as the food goes through the stomach, it'll get down into the small intestine, and it'll kind of get dumped here into the small intestine. Tucked behind the stomach, you can see this guy right here, the pancreas. The pancreas is a source of a whole bunch of different types of digestive enzymes, and it's actually going to take all of its little digestive enzymes and it's going to dump them into the first part of the small intestine. And if you look over here, there's three parts of that small intestine, the duodenum being the first part, the jejunum being the second part, and the ileum being the third part. So as the pancreas dumps all of its enzymes into the duodenum, that allows for those enzymes to start working on the digestive bolus that we are working through. So in terms of carb digestion, the primary enzyme that we're looking at from the pancreas is going to be called pancreatic amylase. So this is again pretty straightforward for us to know where it's coming from and what it's doing. It's telling us that it's from the pancreas. It's telling us that it's amyl, meaning it's breaking down carbs, and it has ase as the ending on the word here, telling us that it's an enzyme. The pancreatic amylase is going to be really helpful for us to continue to break down all of our carbohydrates, those big long chains of carbohydrates that we have, into mostly some disaccharides and smaller forms of carbohydrate. And not only do we have pancreatic amylase in the small intestine, but we also have something called brush border enzymes. And these are going to be a type of enzyme that are secreted specifically by the microvilli that are found within the small intestine. So if you're familiar with the anatomy and the layers of tissue in the small intestine, you'll know that the very surface level layer that's going to be interacting with the food has a bunch of these tiny little microvilli on it, or little finger-like projections out of the tissue, and those themselves are going to have additional enzymes that they produce, and all of those enzymes are going to be really essential for us to go from disaccharides to monosaccharides. And being that our goal form for our carb digestion is this monosaccharides, that will help us get all the way from, again, that larger food that we consumed to the small form of monosaccharides that are going to be ready for absorption. So then throughout the small intestine, you'll see that there's going to be the absorption, primary absorption of the monosaccharides happening. So if we're thinking about absorption, that's going to be occurring in the small intestine, and it's going to be happening through mucosal cells. So the mucosal cells that line the small intestine will start to absorb those monosaccharides, and then they'll go from the mucosal cells into the bloodstream. If you want to know specifically how they're transported, the glucose and galactose are going to be transported through active transport. This means it's going to require some ATP to be able to get the glucose and galactose to be absorbed into the bloodstream. And if we're thinking about fructose, our third monosaccharide, that's going to be transported through facilitated diffusion, which really means that there is some sort of transporter within the cell membrane that's going to allow for the fructose to go from outside the cell to inside the cell, but it's not going to require ATP like glucose and galactose are going to require for that transport. So once all of those monosaccharides have been absorbed in the small intestine, all of that will get into the bloodstream and will actually move through the bloodstream to their target location of the liver. And within the liver, those monosaccharides will then be likely converted into glucose, and then they can be transported to the body cells to help provide the rest of the energy that the body might be needing. And if there is excess glucose that is consumed, then you'll see excess glucose stored in the liver as well as in skeletal muscle in the form of glycogen. So once we've seen our bolus move all the way through the small intestine, you'll see that it gets dumped into the large intestine. So once it's in the large intestine, we will see some little bits of remaining carbohydrates still within our bolus, but we really should see most all of our smaller forms, those monosaccharides, should have pretty much all been absorbed in the small intestine. So most of what we have left is going to be things like fiber. The fiber is going to be really important in the colon because the soluble fiber in particular can start to be fermented by the bacteria that live in our microbiome. So you've probably heard about the gut microbiome. It's a bunch of different types of microbes that will feed off of whatever we have in our colon, and it will start to use all of the fiber, ferment it into things like gases and short-chain fatty acids that can actually be utilized by our body. So this is going to come into play when we have things like fructooligosaccharides and things that we can add like prebiotics into enteral nutrition formulas. So all of those kinds of different types of fiber are going to be very beneficial to our microbes. Once our microbes have had a chance to kind of eat through what they want and ferment all of the different types of fiber that they're interested in, then all of the remaining bulk of the bolus will, of course, pass through the colon and then be excreted. So now that we know a whole bunch of things about carbohydrate digestion, now the question might arise of what does that have to do with nutrition support? So we already know that the various placements of feeding tubes throughout the GI tract can impact the different types of digestion that can occur. If you're bypassing the mouth, if you're bypassing the stomach, that's going to impact or change some of the ways that you might see carbohydrate digestion happening. But we'll also see beyond that some things that have to do with carbohydrates that maybe are going to impact our choices of formula. So the first thing that I want us to think about is lactose intolerance. So lactose, remember, is a disaccharide. So if you have a disaccharide, that's the two-chain type of saccharide or carbohydrate. So it's a simple carbohydrate. And people who have lactose intolerance are actually not able to break apart that lactose into its two monosaccharides. So this can lead to inability to digest that, and it can cause things like gas and nausea, cramping, diarrhea, etc., all sorts of things that are not good and not fun things for the GI tract. This typically happens, again, because you can't break apart the lactose, and that means that they don't have the lactase enzyme, which is one of the brush border enzymes that we talked about earlier. If a person doesn't have enough lactase to break apart the lactose, that can lead them to having intolerance of whatever it is that they're consuming that has lactose in it. So for our purposes, if we're considering enteral nutrition, we have to think whether or not our enteral nutrition formulas have any lactose in it and if they're going to be allowable for our lactose intolerant patients. Well, lucky for us, because there are a lot of people that have lactose intolerance. Actually, most enteral nutrition formulas are made without any lactose in it. So they're made lactose-free so that our patients who might have lactose intolerance will still be able to tolerate their enteral nutrition. So the last thing I want to touch on today is whether or not you want to provide fiber within your enteral nutrition formulas. So lots of formulas have fiber and lots of formulas don't, and sometimes it's challenging to know which one to pick for the specific patient you're caring for. Of course, the instances are always going to be unique based on the individual person that you're working with, but there are some cases that there are kind of some green flags that sound good for using fiber and some red flags that sound like, oh, maybe fiber's not yet appropriate. So some yeses, some green flags, might be if an individual is hemodynamically stable. This could be a person that's in the ICU or not in the ICU, but if they're hemodynamically stable, that's a good sign for considering the introduction of fiber. Also, if someone is not experiencing any enteral nutrition tolerance issues, that's a good sign for the start of introducing fiber. If someone's going to be on enteral nutrition for a longer period of time, we definitely might want to consider adding fiber if it seems appropriate. As we've already talked about, there are recommendations that most patients get fiber throughout the day based on our adequate intake recommendations from the USDA. So if we can provide that fiber to them in enteral nutrition, that could be a good thing for them. And finally, you might have patients who are experiencing persistent diarrhea, and sometimes providing fiber can help to create more solid stools so that they are less likely to have diarrhea. So if we're considering some of the red flags that we might see in a patient, although we are seeing some potential changes in recommendations, for the most part, if you see a patient who is not hemodynamically stable, they're probably not ready for enteral nutrition at all yet, so they certainly won't be ready yet for the introduction of a fiber-containing formula. As patients start to get more hemodynamically stable, even unless they're having some really severe GI dysmotility or dysfunction, the proposition of including something like soluble fiber may be an option, but really it's going to be specific to that individual patient and based on their total gut function. If you're also considering patients who have bowel ischemia or severe dysmotility, those patients are probably not going to be appropriate for the introduction of fiber just because they're not really seeing clear movement of passage of things through their GI tract at this point. So the introduction of fiber, which could potentially slow down or create additional solid substances of stool, that's not going to be very beneficial for those patients as they're already having some GI difficulty. So a few different considerations for you there in terms of fiber, and also plenty of things to think about hopefully today in terms of carbohydrate content and how they might be digested and absorbed in your patient who is either on an oral diet or who is receiving enteral nutrition. We hope that this video was helpful to kind of bring you back to the basics and reintroduce or speak through some of these topics. If you want to see more in detail about the absorption and metabolism of carbohydrates in the system, please let us know. And we'll have videos coming to you soon in terms of protein and fat digestion. So lots coming to you. Please leave any questions in the comments boxes below, and we'll see you next time.